Hello everyone, I'm extremely sorry for the delay. We'll be starting now without any further delay. As a brief introduction, I'm Monalisa from IIT Bhubaneswar, and today in the session of Ask Me Anything, I'll be making you go through a couple of 10 to 15 questions. So the first question I received is regarding the Lanthanoid contraction and consequences. So in Lanthanoid contraction and consequences, here So the first question we got is Lanthanoid contraction and consequences. So let's solve this question. First, before, what is lanthanoid? Where do we find lanthanoids? So lanthanoids are from F block, right? F block. When we are talking about periodic table, we have like in periodic table, sorry for this. In periodic table, we have different blocks like S block, P block, D, and F. So in that, S block has two parts, actinoid and lanthanoid. So to show the what are lanthanoids, let me take you to the PPT. So these are lanthanoids. These are lanthanoids. And when we are talking about lanthanoid contraction is nothing but these elements of lanthanoid series, that is from 58 to 71, they show similar kind of sizes. Usually what happens when we go down the group or from left to right, there is variation in the size of atoms. But when we are talking about lanthanoid series, in lanthanoid series, the change is very negligible. Like we can say that the CE and PR has similar size, but in reality, for other groups, it is not valid. So this is what the major effect of lanthanoid is. Lanthanoid contraction is. And there is one more thing. There are three major things about lanthanoid. Those are, there is regular. So let me write it well so that you can make a notes of it. Okay. So they in lanthanoid contraction, there is regular decrease, or we can say contraction in atomic and ionic radius, where in the lanthanoid series, and how does it take place? It takes place with increase. जैसे जैसे atomic radius increase होगा, वैसे there is regular decrease in the size with increasing atomic number. Increasing atomic number. Okay, so this is major thing about lanthanoid contraction. So when we decode it further, we will understand from left to right in the periodic table this takes place. That is in the lanthanoid series, of course. So there is, why does this happen? We are talking about 4F, right? The lanthanides belongs to 4F, isn't it? So why does it happen? It happens because of poor shielding of 4F electrons. So that is the reason why there is lanthanoid contraction. So in short, overall, the lanthanoid contraction is due to poor shielding of 4F electrons. And what are the 4F electrons? The lanthanoid series, the whole this 58 to 71 undergo this contraction. Okay. And what are its consequences? We have understood what is lanthanoid contraction, but what are its consequences? So when we talk about consequences, we have majorly, this is where some questions can be found. So there is similar or nearly same radius. So there is no separation. We cannot differentiate which has much, which has higher radii or less. That is Z and that is Zn and Nb. They both, Zn and Nb, have similar size, and HF and T, they have similar size. This is one of the consequences. So, and the second consequence is the second consequence would be there is decrease in the basicity from left to right. Decrease in basicity from left to right. From left to right. So example, let me give you an example. So LaOH3 to LuOH3. It has the it is most basic and it is least basic. So this you can consider as one of the reasons, one of the consequences basically of the lanthanoid series. Okay, and one more thing about lanthanoid series is that when we take La plus 3 and Lu plus 3, from La plus 3 to Lu plus 3, the size decreases, and the covalent coordination of hydrogenated will increase. So we have seen the major three consequences. One overview of the lanthanoid contraction. So This was our first question. Moving to the next question. So the next question. So let's come back to the question. That is the chemical bonding. What is chemical bonding? So we are learning chemistry, so it is important for us to understand chemical bonding. In short, when we talk about chemical bonding, a most simplest understanding of chemical bonding would be, what do we understand by bonding? For example, let me give a better example. For example, we have salt, we have glucose, we have water. Okay. What does salt contain? NaCl, right? What does glucose contain? CHO. What does water contain? H and O. Of course, H2O. I mean, what are the atoms it contains? These are the atoms. So when we are talking about what is making both of them bind, what is binding them? Of course, attraction, attractive force, isn't it? So attractive force is binding them. So the attraction force between two atoms and molecules to form a chemical compound is what we term as chemical bond. So whatever is binding NaCl, sugar, NaCl, HO, CHO, all these are bound by attractive forces, and these attractive forces we term as chemical bonding, which form chemical compounds. The simplest example, me being a going to be a civil engineer, like we have two bricks. So the cement is the thing which binds them. So similarly, two molecules, two elements are bound by bond. So that is what we call as chemical bond in simplest terms. And what are the why does chemical bonding happen? Why? What is the reason for chemical bonding? The reason for chemical bonding is, why do any element want to undergo chemical bond? Because it wants to lower its energy to get stability. It wants to lower its energy because it wants to get stability, right? So this is the reason for why chemical bonding happens. And how do we measure chemical bonding? When we are understanding what is chemical bonding, it's also important for us to understand chemical bonding, right? Like what is the reason? So how do we measure chemical bonding? So for measuring, we will see the completion of duplet or octet. Like if any element has two valency, then it can form a bond. Like it is a stable thing. So there is no need for it to form a bond. So usually there are three types of bond. Okay. Chemical bonds. One is ionic. Okay. One is chemical. One is covalent. Another one is metallic. So ionic happens between metal and non-metal. Covalent happens between non-metals. Like for example, water, H2O. These are non-metals. Salt, Na and Cl. It is a metal, Na and Cl. They are metal and non-metal. And metallic, like gold. So these are few examples I could give you. So this was the answer for what is chemical bonding. We have understood what chemical bonding is and why does it happen? How do we measure? So next, let's go to the next question. So I have arranged questions in such a way that it would be easy to understand. So next is covalent bonding. We understood chemical bonding is of three types, and one of them is covalent bonding. So let's understand what covalent bonding exactly is. So when we are talking about covalent bonding, it happens by mutual sharing of electrons. For example, there is Cl2. What is the atomic number of chlorine? 17. So what is the distribution? 287. The electronic configuration distribution is 287. So Cl, there are 7 electrons in the outer orbit. 1, 2, 3, 4, and 4, 5, 6, 7. So there is it is one electron away from octet. So another Cl also has similar bonding. So what happens? The bonding happens by mutual sharing of the same one electron. Okay, each atom is sharing one electron. So this is how bonding happens. For example, let's take N2. What is the atomic number of nitrogen? 2. It is 7. So 2, 5 is the configuration. So 1, 2, 3, 4. Nitrogen. 5. 1, 2, 3, 4. Here, 1 second. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So even if we consider like this, whatever the bonding will happen, it will happen by mutually sharing of these electrons. Like there will be 3 bonds for this, right? So this is what we meant. The example of Cl2 confirms what about the covalent bonding. Okay, so proceeding further, we understood what covalent bonding is. Now let's go forward to the next question. So the next question is, it is regarding covalent bonding we have done. Next is about periodic table. The next question, let's take a periodic table shortcut. How should we learn periodic table so that we will remember? So there are few mnemonics for that. Let me tell you the mnemonic, and it will be very easy. Let's make it in a very interactive way. So इधर ये mnemonics के लिए let's consider the S block elements, group 1 elements, H, L, I, N, A, K, R, B, C, S, F, R. So the mnemonic for it is the mnemonic for it would be Halina की रब से फरियाद. So the mnemonic is Halina is a, let's consider as a one person. Halina की रब से फरियाद. Faryad means, we know, like complaint. So H represents hydrogen, Li lithium, Na K Rb. Say we should remember as Cs. Fr. This is one for first group. And next, What is the next one we have? The next one is group 2 elements. Here the trick for this is beta, Monge, car, scooter. So let me write it clearly. First trick is her Leena ki rab se faryad. If you repeat it after me twice and make a note of it, it will be easy for you to remember. So, and the next one is beta, Monge, car, scooter, baap, Razi. This is another statement. So what is the mnemonic for this? What does this mnemonic imply? It implies beta, BE, Mange, MG, car, scooter, baap, Razi. Okay, and next one. Let me tell you once. All. Next is for the group 3, Scandium. Okay. So Scooty, Yamaha, Lao, Ek. This will be the mnemonic. That is Scooty, Yamaha, Lao, Ek. This is mnemonic for the next one. Next is T zera half. Like T zera half. Titanium, ZR and HF. T zera half will be the mnemonic for the next. Next is V, vanadium. So wo Nawab tha. Wo Nawab tha will be the mnemonic for the next one. Wo Nawab tha. Next is chromota. The W is symbol for tungsten, you know, right? So for that, the symbol will be, the mnemonic will be chromota. 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 Okay. Next is Mantakre. Mantakre. MNTCRE. Mantakre. This is Fe means ferrous, right? So for that particular group, ferrous itself is FERUS. Ferrous. That itself is a mnemonic. Ferrous. FERUOS. Like ferrous. Like we can understand FERUOS. So Fe stands for ferrous. And uska mnemonic bhi kya hai? Ferrous. FERUOS. Next is the next would be कौन रहेगा आयरलैंड. कौन रहेगा आयरलैंड. Okay. CORHIR. कौन रहेगा आयरलैंड will be the mnemonic for that. Next is नहीं पढ़ोगे तो पिटोगे. नहीं पढ़ोगे तो पिटोगे will be the mnemonic for the next. नहीं पढ़ोगे तो पिटोगे. NIPD नहीं पढ़ोगे तो पिटोगे. ये तो डायरेक्टली याद होना चाहिए कि ZnCdHg, these are coinage metals also. This is one of the important things to remember. ZnCdHg. Okay. And for the 13th group, Vegan, Aloo, Gajar in Thailand. Vegan, Aloo, Gajar in Thailand. For the 13th. और next is 14th group के लिए हो सकता है काशी गए संत प्रभु. काशी गए संत प्रभु. Okay. Now next 15th group के लिए ना पास सब बकवास. ना पास सब बकवास. 16th के लिए ओ स्टाइल से तेल पॉलिश. ये अगर कोई एकदम पॉलिश जूते पहन के एकदम तेल लगा के एकदम स्टाइल से, तो क्या आप बोलते हैं? वो स्टाइल से तेल पॉलिश. ऐसे याद कर सकते हो आप लोग कि वो स्टाइल से तेल पॉलिश. नेक्स्ट F, ये हाइड्रोजन ग्रुप के लिए फिर कल बाहर आई आंटी. दिस कैन बी निमोनिक कि फिर कल बाहर आई आंटी, फिर कल बाहर आई आंटी. ओके, फिर कल बाहर आई आंटी. आई एम रिपीटिंग ताकि ऐसे याद हो जाए आप लोगों को. यू कैन रिपीट आफ्टर मी. ओके, फिर कल बाहर आई आंटी. एक बार निमोनिक लिखना, उसके नीचे एलिमेंट्स लिखना, याद हो जाएगा. नेक्स्ट, ही नेवर अराइव्स ऑन टाइम. दिस कैन बी, अपन को नोबल गैसेस तो पता ही होने चाहिए. हीलियम, नियॉन, आर्गन, क्रिप्टॉन, जेनॉन. ही नेवर अराइव्स ऑन टाइम, ये हो सकता है. ही नेवर अराइव्स, एक इंसान का नाम कर्जी, लाइक ही नेवर अराइव्स कर्जी. यू कैन ऐसे याद कर सकते हो. ही नेवर अराइव्स कर्जी. तो फिर से एक बार पूरा रिवाइज करते हैं. निमोनिक, इसका फर्स्ट ग्रुप का ह ली ना की रब से फरियाद, बेंगन आल बेटा मांगे कार स्कूटर बाप राजी, स्कूटर यमहा लाओ एक, टी जरा आप, वो नवाबता क्रोमोटा, मंतकरे फेर्रस, कौन रहेगा कौन रहेगा आयरलैंड, नहीं पढ़ोगे तो पिटोगे. हाँ, नहीं पढ़ोगे तो पिटोगे. And when we were talking about ZnCdHg, we said that there were coinage metals, right? Coinage. And one more thing I would like to mention about ZnCdHg is these are there is in D block elements. We talk about, sorry, when I was saying that ZnCd, sorry, CuAg, Au are coinage metals. Okay, Ag, Au are coinage metals, and ZnCdHg are transition but not D block elements. Are D block elements but are not transition elements. Okay, so this is one exception about them. So, for 13th one, it is Began, Alu, Gajar in Thailand. फिर 14 काशी गए संत प्रभु, ना पास सब बकवास, ओ स्टाइल से तेल पॉलिश, फिर कल बाहर आई आंटी, ही नेवर अराइव्स ऑन, he never arrives Karziran. He never arrives Karzi. Karzi can be considered as name of person. So this is the mnemonic. So this question is done. So moving forward to the next question, F block elements. So we have studied the F block elements are nothing but we have 4 blocks, right? So one of them is F block, and F block elements. F block lie much inside than D block, right? Much inside than D block. So these are in relation to transition metals naming one F block specifically, and these are called as inner transition elements. Okay, what do we mean by inner transition elements? First of all, let me tell you properties of F block, so you can make a note of them. So F block, they have electrons added to the F suborbital of n-2 level. First thing. The second thing is these are placed between n-1. These are placed between n-1 and ns block elements, right? N-1 and n-1 D and ns block elements, these are placed. And these properties are similar to of D block. So that's why the name is similar, like inner transition elements, as the name suggests. inner transition elements. So in F-block there are two things, lanthanoid and actinoids. We have studied about them, about lanthanoids, a brief about lanthanoid contraction. Let's study more about lanthanoids a bit, right? Like lanthanoids are, let me tell you a few properties. It will be useful. It can be a direct question as well. Lanthanoids, like these are like soft metals. They're soft, they're silvery white in color. And these, the color of them dulls bright, and brightness reduces with when they're exposed to air. They say जितना हवा को रखेंगे उतना brightness कम होगा. And high melting, they have melting point from like 1000 Kelvin to 1200 Kelvin, except there is one element called as marine, which has 1600 Kelvin. So they are very nice high melting points. Okay. So this is one thing. And when we talk about, they are also good conductors of heat and electricity. They are non radioactive in nature. That is radioactive. That is atomic and Li to Lu. So this is observed as the next one is the property of activities. So not this. These are silvery color, and they are radioactive in nature. But as they are radioactive, these metals are very highly reactive. Okay, these are very much like highly reactive. One more point which is very interesting about actinides is as they're highly reactive and the reactivity is finely divided. The reactivity of these actinides is finely divided, and these exhibit usually pleasant oxidation state, like the first half of the series, and are very high oxidation state, which we have seen very frequently. When you may ask what is the difference, or lanthanoid is 4F, like the of 4F, and actinide is 5F. Okay, and the binding energy is also different. Of 4F electrons is comparatively less than of 5F electrons, and so the shielding of 5F is less effective than 4F electrons. And one more thing is the paramagnetic properties. We can easily understand the paramagnetic properties of lanthanoids, but not about actinoids. Usually, F block का समझना ही मुश्किल है, but compared to lanthanoids and actinoids, it is easy to understand lanthanoids. And also, lanthanoids are non-radioactive, but actinoids are radioactive. So these are few differences about them. So next, so I think we understood very well about F block. So moving to the next question. Okay. Okay. There is a question, melting boiling point of Z and CD Hg are low. So we just now saw what are Z and CD Hg. So let's talk about them. Z and CD Hg. Which block do they belong to? Which group do they belong to? Let's go back to the table and see. They belong to 12. So group 12, Z and CD Hg. They have they do have boiling point. So the reason is they are element of group 12, and these are quite soft. Also, this causes them to have low melting points. Low melting points. And you can see that mercury, the Hg, is a liquid, right? Is a liquid at room temperature and melts at minus 38 degrees Celsius. So these three elements are very typical in behavior because there are no unpaired, and one of the reasons also can be there are no unpaired electrons for them to be metallic to make for metallic bonding, and therefore their melting points are low. As there are no unpaired electrons, the melting points of them are low. So the straightforward answer for this is no unpaired electrons is the reason. Okay, so this was a quick question. The next question is, okay, let's talk about monosaccharides. So this is a very interesting point about monosaccharides, and we can see very enough content about monosaccharides. So in short, let me explain you in short. We know carbohydrates. What are carbohydrates? What do you understand by the term carbohydrates? Usually, it's not nothing technical, but usually what do we understand? Carbohydrates are basically sugars, right? So the chapter from which when we see a chapter from where we got this question, let me give a plot of. So biomolecules are divided into carbohydrates. We'll come back to the question: carbohydrates and nucleic acids. Okay. Carbohydrates are again divided into sugars and non-sugars. We usually see that carbohydrates are always sugar, but it's not the case. Carbohydrates can also be non-sugar. So sugar and non-sugar. So what does sugar mean? Sugar means sweet in taste, that crystalline and soluble in water. What does non-sugar mean? That amorphous, insoluble. Okay. So, and these sugars are again divided into monosaccharides and oligosaccharides. And monosaccharides are divided into aldehydes and ketones. So, term which we have been searching monosaccharides has here. So, it is one of the it's nothing, it's not just simple sugars. Monosaccharide name suggests it is a simple and it's not hydrolyzed. As it is simple, not hydrolyzed. Like for example, glucose, an example. And we spoke about the aldose and the ketones. Right? It's a group. It's a group present monosaccharide. We call aldose. There is ketone group in the monosaccharide. We call as ketose. Okay, so this is basic idea about what is monosaccharide. What are monosaccharides? I hope you understood what are monosaccharides right now. And let's move forward. Let's the next question. Using method. So it's a very and the practice requiring the process. So let me summarize it for you. So balancing chemical equation using ion electron method. Okay, so let me, for example, the first thing we need to do is to write the oxidation number above the atom in the chemical equations. What do we usually balance? We balance the chemical equation, right? So we need to write the oxidation number. We write oxidation number. So let's take one example, okay? So it will be easy for us. Like CrOH3 plus IO3 minus gives rise to CrO4 minus 2 plus I minus. Okay. Okay. This is the equation we have. The first thing we need to write is oxidation number. So Cr, what is the oxidation number? Cr is of +3. How do we know that? See, this is an easy way to understand. And next here, how do we find oxidation number? Like IO3 minus. So let's assume oxidation number of I as X 3. So what is the oxidation number of oxygen? -2 into 6, -2 into 3 equal to -6. Then what is the total charge? -1. So X is equal to O. Okay. So X is equal to 5. It is the oxidation state of iodine. Next is Cr. What is the oxidation state now? So let's assume X -4. So 4 into -2 is 8. -8. And the total charge is -1. What is the oxidation number? 6. So the oxidation number is +6. So this is how we identify oxidation numbers. So we wrote the oxidation numbers. And this is done. The first step is to write oxidation numbers, and we have done it. Now we have to identify that which are oxidized and which are reduced, and we need to split it into two half equations. For example, chromosome is undergoing oxidation and iodine is undergoing reduction. How do we know that? From +3 to +6, it is oxidation. There is increase in oxidation number. And from 5 to -1, it is decrease in oxidation number. So let's make two half reactions. Okay, oxidation half and the reduction half. So CrOH3, excuse me, CrOH3 plus IO3 minus. Okay, we are making the plus half and minus half, right? So, I mean oxidation half and reduction half. So CrOH3 gives CrO4 minus 2 and IO3 gives IO3 minus gives I minus. Okay. Now the number of electrons gained should also equal to the number of electrons lost in the chemical equation. The gain and loss should be same. So the balance we need to gain or lose has to be done by balancing the atoms first other than of H and O. First we need to balance atoms other than H and O. So there is one other than H and O we need to balance. So chromium is balanced, iodine is balanced. Okay, this is simple, it's balanced. Now for one atom of chromium there is loss of 3 electrons, like the +3, right? And for one iodine there is gain of 6. So in order to balance, let's multiply this by 2, both sides by 2. So here there should be, basically here there should be plus, here it should be plus 6 electrons, y is plus 6 electrons. Just a second. Okay, so we are going right. So here the charge, as per the charge and as per electrons, this is what the equation we will get. And here the charge is 6 electrons, so that we will be getting what is here the charge as per the charge. Okay, we will balance the charge first. To balance, now we need to balance hydrogen and oxygen atoms. So we need to add equal number of water molecules on both the sides. On the side which has excess oxygen, and we need to double the amount of hydroxyl on the opposite side. So on the side where there is excess of oxygen, we will add double of hydroxyl ions. See, for example, let me make you understand with this. For example, here the Cr plus 3, here we will get 2Cr plus 3 plus 16OH minus plus 3H2, which gives rise to I minus plus 6OH minus. And similarly, I 3 electron plus H2O gives I minus plus 6OH minus. Basically, to conclude, we need to first understand the oxidation number, then balance everything other than oxygen and hydrogen. Then we need to balance hydrogen and oxygen, we need to add equal number of water molecules on both sides. And wherever on the side there is excess of oxygen, we need to double the amount of hydroxyl ions and add it on the opposite side. It is a bit complex, but when you see the process, it will be easy for you to understand. So yeah, so this was all about now. There are a few questions which are still left. We will talk about them further. So I hope whatever is discussed till now is understood. So yes. So here we end our session. So thank you so much. Have a great evening. Thank you.